string-shattering screens, feverish filaments forcefully fighting, and bigger beds, bigger blunders, all this and more. PrintFix Friday, episode 154. That took like 4+ attempts. Let's get into it. Starting off, we got my buddy Alan Mandic of Mandic Really and the Mandic Labs channel. If you don't know him, make sure to go over, show him some love. Alan here has recently relocated across the country into, let's go with a slightly more unpleasant atmosphere. And his office has been getting well over 90 degrees Fahrenheit, 32°C for all of you normal people out there. And, well, he's got one heck of a heat creep clog in his Mark IV. We talked about this one before, that if you are in a more just unbearably hot climate, it's gonna be what it's gonna be. You're gonna have to better cool everything by having more air go across your heat breaks. You're gonna have to go up to a more high temp-rated filament like PETG, or you're just gonna have to pray, I guess. Thoughts and prayers out there for all of those that are running their printers in the swamp or the desert. Godspeed. Myself included. I know this pain all too well. Not indoors specifically, because the air handler for my entire shop is in the same room that I'm in, but certainly on our garage set, where in the heat of the day, I cannot get the temperature below 87 degrees Fahrenheit in that garage, or below 60% ambient humidity. It is rough. A lot of people would call it unbearable. It's livable, it could be worse, but it's not good for 3D printers. They're not designed to operate in temps like this. Traditionally, you see heatsink temperatures like, 10, 20, 30 C above ambient. The problem is, that is very close to the softening temperatures of quite a few filaments. At even 10 C above ambient, which is 32 C for Mandic here, so you're looking at 42 C, you are well within the softening point of PLA to cause heat creeps. And this is unfortunately where these single nozzle heat break combination systems absolutely fall flat. They suck when they get heat creep, because you can't just easily fix it. It's the entire freaking thing. So you have to take the part out, you have to heat up the tube, and then pull everything out. It's not all that easy. And quite frankly, it's more of the labor of having to stop the print, swap everything over, the print's gone, you've wasted time, and you must have spare parts, or your machine is going to be down until you can get those parts back in place. It's why we stress the massive need to have spare parts on your machines when and where possible. This is one of those environmental factors that you just can't always control. Now, Mandic has been fighting this tooth and nail recently by installing a pretty large and high CFM fan to help cool the upstairs of his house where his office resides. And in that video, which we will link to so that if you do want to watch it, you can, this fan increased his cooling capabilities by quite a bit. While still the room is quite warm, it's like 5 or 10 degrees Fahrenheit below what it was. And buddy, that's a win in my book. But when we look at situations like Mandic's here, there's really only one good solution. It's extra air conditioning. And hi, by the way, welcome to PrintFix Friday. If you don't know what this is, we help you get your printers back to printing with purpose, and we're here to help. So if you have a 3D printer that is giving you some issues, you can reach out to us on all the social medias, although Twitter and YouTube are the best ways to reach me. Use the hashtag PrintFix. We'll see what we can do about including it in a future episode. That's where I gotta pass it off to you guys. Is the answer just, I don't know, print with PETG more often? Do you, because adding a multi-$1,000 air conditioner, like $5,000 or $6,000 air conditioner for a 3D printer seems excessive. How would you solve this problem? And please, let's not just go into the ship of Theseus issue or the Prusa of Theseus issue where we just start liquid cooling everything, because while yes, that would technically be more efficient, come on. If you're gonna go hard in the paint, at least use a Seebeck generator or a Tech a thermoelectric cooler, as a lot of you would know it, so that you can not only keep your heatsink cool, you can heat your chamber. I'm just saying, that'd be a really cool idea. Would you want to see a video of us doing that? I'm a little concerned now that I've talked about it. Anyways, let me know in those comments, and hey, maybe we'll do something stupid. Why not? Moving on to the ultimate Prusa durability test. This is you. This is the guy she tells you not to worry about. This here, Prusa XL from Patreon Discord member Secret Squirrel, which if you do want to join $10 tier and higher on any of the platforms, PayPal, Patreon, YouTube channel members, links where you know where to find them. A Secret Squirrel here found out that unfortunately a 3-kilogram roll of filament dropping from at least the height of an XL onto the screen of an XL will destroy the screen. And while technically I believe the screen should still work, the touch screen is definitely not going to function. And yes, for reference, this is a 3-kilogram roll of white filament. Comgro, why did you send white filament? White is the worst color for filament. And this is a printed solid spool of gold winter glitter. It is a big difference. You're talking, you know, 2.2 pounds, 6.6 pounds. And when it's falling from that kind of height, there's a lot of force involved in that. Somebody will calculate it. Let's just assume it fell from a meter high. How much force was being imposed on the screen of the XL? Let me know in those comments. And you might say, Grant, I'm not going to have this problem. And I would say, good. And I bet Secret Squirrel is not going to have this problem moving forward either. This is one of those cases of it's probably okay right up until the point that it's not. And it actually makes me really worry for the spools that we hang above the screens on the printers themselves. But if the spools fall, they don't actually hit the screens, they're pushed back a little bit, it'll hit the front of the actual shelf. Is this a concern that we should have with our printers, like having things fall and hit the screens? Right, you can build an armor casing, if you will, for the XL screen, and I kind of recommend you do to some extent because it sticks out and you can run into it. We have one built, I just don't have it installed because I actually printed it too large. That's a later Grant problem, it's not a current Grant problem. This is one of those cases of it's probably okay right up until the point that it's not. But unfortunately, this is a $92 plus shipping kind of problem, and that kind of sucks. I would definitely not fix it if it still works perfectly fine. And now with the brand new app that Prusa has, assuming you're not doing anything where putting the machine on a network would not be an issue, you theoretically don't even need the screen. So I don't know. It is broke, but do you actually need to fix it? Let me know your thoughts in those comments. It seems like we've been getting a lot of Prusa XL fails. This is not intended to be clear. It's just what happens to pop up in my feed. So, hey, Prusa XL owners, make sure that your Nextruder nozzle is actually attached and reasonably tight inside of the tool head, or you're going to have a bad time like my buddy, Mr. Peter Sassaman here, who, if you don't know, makes the Cilia, which is the Scent VR, and he also is working on some haptic feedback gloves that are super freaking cool. But unfortunately, Peter here has lost an Nextruder nozzle, RIP in pieces, F's in the chat, if you will. The grub screw got loose and it broke against the print. So you might say, Grant, what? How does this happen? Well, it's the same way that if a Revo comes unscrewed, it will eventually start digging into your build plate, damaging your parts and everything like that. It's quite complicated. And on the XL, unfortunately, it is just one grub screw that holds everything in. So if that grub screw comes loose, your nozzle's gonna have a bad day. I don't know if Prusa recommends it. I might, but I can't get behind it immediately. Maybe some blue Loctite, or maybe even some like Elmer's glue, something to keep that grub screw from backing out. Theoretically, if you torque it down correctly, which is not a ton, just barely tight, it shouldn't come back out. But it's not impossible. It's like every single time we have a nozzle failure, I get just a little more paranoid that my nozzle is just gonna randomly fly out of my machines when they're running. This is unfortunate because it is a relatively expensive fix. You need a brand new nozzle. If you're lucky, all you need is that Nextruder nozzle, and they're like 30, 40 bucks. So, okay, not too bad, I guess. But you have to make sure that your heater, thermistor, and nothing else is broken in the way. You can see on the actual build plate of the XL, the part looks bad. So how can you avoid this, right? The best thing you can do is check those grub screws, check them often, make sure your offsets are set correctly. And if you adjust any of your nozzles on your XL, you really should rerun the calibration for it so that all the tools can realign. It's not that difficult, but it uses T0, which is the first tool, but it's T0. Work with me, that's just how it is in the industrial world, but it uses T0 as the perfect one, and everything post is a factor of how much offset it is from the perfect one. Take note of that, check your grub screws, and if you're wondering, how do I do that? Prusa has a great article on how to change the nozzle, which will alert you to where the actual grub screw is located on that actual docking plate for the XL itself, right in there, where the blue arrow is pointing. So I gotta ask, has this happened to you on your XL? It is harder for me to see this happening on the Mark IV and the Mark IVS because they have thumb screws, right? And there's two of them, versus the XL that only has one grub screw. It's definitely more likely, but these are all things that were done, I think, to do their best to save space and not have things get too large where you would not be able to fit as many tools on this machine. If you've ever seen a 5-tool head XL, those tools are about as close as they can physically get. Any closer and they're going to start hitting each other. Next up from Discord member Nalai, who is having some fun issues on one of her Bambu printers. It's not the clearest photo, but it's pretty clear to me what's going on. She's been having intermittent extrusion issues. She's trying to do little jewelry things and cosplay parts, things to sell to friends. We can see that these drive gears are absolutely gummed up. And there's also grease on these gears. I know on the X1 Carbon, that's not common, but I'm not certain if this is from her X1. It looks like it might be. This looks like an X1 extruder, but it could be from a P1, and I have no clue what the extruder looks like on the A1 series. But the teeth on the extruder are absolutely caked in filament. The best way to do this, from my experience, is to get a 90-degree dental pick, or just a pick for O-rings. Harbor Freight sells them. They're cheap. You can buy them on Amazon. We'll link to some in the description if you want to buy some. But they're great for just picking out that bit of filament. You can also use a stiff brass brush. And you might have heard us talk about the firearm cleaning brushes that we recommend. They're either copper or they're brass. They are great for this because they have a side with longer bristles, but they also have a side with shorter, stiffer bristles that will definitely get that caked filament out. So how does this happen? You have to have a clog of some sort, whether it's a heat creep clog, a nozzle clog, some sort of clog post the extruder, where the extruder, instead of skipping, just starts grinding into that filament until the filament just straight disappears, and it grinds itself into the actual gears of the extruder. There is not a good way that this just fixes itself over time. It often does require disassembly, and if you'd like, we can do an entire video on this. It's pretty easy to force printers to start grinding filament. Just reduce their extruder pressure, and then you just hold the filament and keep it from going in. It normally will turn out like this in a few seconds of time. But if you've ever had a heat creep issue where the printer was clogged and it wasn't skipping steps, you will want to check your extruder drive gears to make sure that they are clean and happy, because if not, you might be dealing with some extrusion issues, and nobody wants that. So I'd love to know down below, has this ever happened to you? Have you ever dealt with a clog that's absolutely destroyed your drive gears? Because the next one actually destroyed the drive gears. This one comes all the way down under from Discord member Tasmaniac Guitars, who has bigger printers with bigger problems. This is an absolute monster of a machine. To give you an idea, the filament is 2.85 millimeter, which tells you it's a big girl. And if I'm correct, I'm fairly certain, given the orange corners, that this is a big rep 3D printer, which are incredibly expensive, but they have insanely large build volumes. We can see here that we have some grinding issues, to say the least. This is a case of where you have been grinding filament so long and that it's carbon fiber, your hobbed gears on your extruder are completely and utterly shot. There's no chance of fixing that. Those are worn down. It is time to replace it. So from the man himself. So I often hear people talking about wanting a large-scale printer and how cool it would be to print things. But you also have to stop to consider with large-scale printing comes large-scale problems. No one checked on this print while I was away. The toolhead is currently where the print thinks it is finished. Some of the failure and the aftermath. I can't believe I'm actually saying this because the moment anyone claims bad filament, I get highly suspicious of the printer or their ability to run the printer. But this is quite literally a bad batch of filament that has so far cost Big Rep over 150,000 Australian dollars. The material being printed is what they call high temp CF, a PLA-based polymer with approximately 20% carbon fiber mixed through it. They determined that they had a bad batch of material and consequently replaced everybody's 8 kilo spools. You saw a 3 kilo spool earlier. Imagine what 8 kilos looks like. When the issue began to reoccur for a select number of customers, Big Rep sat on their heads and did virtually nothing until one of our customers complained so hard, rightfully so, due to having nonstop issues with the machine since taking ownership 8 months prior, that they replaced the entire machine for this individual. When we did some further testing on the new filament, we found that even the new batch filament had just as many issues. Consequently, Big Rep were forced to replace the spools a second time. So how was the filament a problem? Great question. I'd like to direct everyone's attention to Grant's video regarding what is in filament and what is not being disclosed properly. We'll card to that, so you can take a look. This is a prime example of that. Turns out, 2 things had occurred during the production of the material. Firstly, an additional polymer had been added into the blend to increase the glass transition temperature of the material. That mixture had changed slightly, requiring a higher print temp. That's okay. Secondly, and more problematically, the CF had not been consistently mixed through, meaning there were large chunks of CF deposited through the filament, and the diameter of the 2.85mm filament varied wildly from 2.41 right up to 3.29. That's a lot. And consequently, this material was getting stuck in the extruder. The extruder gears then began to grind on the filament and the carbon fiber. Despite being hardened steel wheels, 8 days of grinding against carbon fiber destroyed the gears completely. Yeah, I really don't have much to add on this one, other than I just wanted to show this one to y'all. But this is one of those kind of hurdles that you have to jump through when you're looking at big time additive. Not only are you using filament that is most likely from the manufacturer, because 2.85 is not a very common size anymore, and especially for carbon, you don't find it all the time. So you have to trust that the first-party manufacturer is going to do it right, which they should, given what they're likely charging for it. But in this particular case, it has been a rightful disaster. And I can't imagine what I would be going through if I was the client here. Because you don't buy a machine like this to let it sit and do nothing. You buy a machine like this to make you money. Look at how long this thing was waiting here. It was printing for days and days and days. This is why we've said before, having a smart plug of sorts, I don't care how you do it on a machine this size, there's got to be a way to install a smart plug and a Wi-Fi camera so you can at least monitor the darn thing. Would save tons of headache. Absolutely tons of headache. Literally, potentially tons of headache. Because this kind of thing is really hard to track down, and this kind of mess is a real pain. Because what you're potentially forgetting is that carbon fiber is mildly conductive. Even the cat knows that. So I gotta ask, outside of I would never buy a Big Reps, this wouldn't be a problem. Let's ignore that. How would you stop a problem like this? I mean, I would say this problem should never make it out of a filament production line, because this is the kind of thing that should get caught. When we made filament at Printed Solid a little bit under a year ago, we'll card to that video so you guys can take a look, and of course we're going back again this year. You know we gotta go back. But they have such tight tolerances and machinery to be measuring the diameter all the time. Outside of just pure laziness, I don't see how this actually happens in a manufacturing life cycle. Now, don't get me wrong. 2.85mm is the average diameter. 1.75 is the exact diameter. It's a little bit different, where 2.85 we often call 3mm because it can vary, but the diameter should be consistent. If it's 2.85, it's 2.87. If it's 3mm, it should be consistent. The wild variation from 2.41 all the way up to 3.29 is almost a full millimeter of size change, and your average Bowden tube that you're feeding this through does not have the space for something like that, and neither do precision-made components inside of a 3D printer. This is why we often are a little bit cautious of first-party materials. You have to make sure they're any good. And if you don't know what's in those first-party materials, I question, is it worth getting it in the first place? These high-speed PLAs and things like that, they're normally mixed with something to make it go faster. Talc is what we know to be one of the more common things that are used in a mixture. And according to people that we've spoken with, a lot of companies will call PLA Plus actually regular PLA. And they'll sell that at a premium, and they'll sell their high-speed stuff at a premium, which is actually costing them less to manufacture. There's a whole thing, and if you want to hear me talk with Mitch from Polar Filament about it, we'll card to it so you guys can take a look. But like, if you're trying to sell a 150,000 Australian dollar-y 3D printer, you should probably have your damn filament game figured out. That's all I gotta say about that. I'd love to know y'all's thoughts in those comments, but there's gotta be a way. Because, like, it's possible on the 1.75 side. You can just measure diameter as you're working. And you could also have a system to detect a filament jam. A roller wheel with a rotary encoder is how we used to do it back in the old day. Now companies are using load cells to determine extra pressure inside of hot ends, which is super freaking cool, and I want to see more companies do it. But how do you envision that we can get around an issue of quality control for manufacturers? Because let's be real, you should be able to trust manufacturers. But wouldn't you feel a little bit more comfortable if you knew you didn't have to, and your machine had its own watchdog, if you will, to verify it all for you? Let me know your thoughts down below. And hey, while you're down there, if you think we've earned it, leave a like and get subscribed, because that really goes to helping us out here on the channel. Just like all the names listed right next to me at the $5 tier and higher, who have helped make videos like this possible now for almost 3 years. 2 more episodes, and it's 3 years since we started PrintFixFriday. Thank you all to what you do in making these videos possible. Even if you don't give us a dime, thank you for watching them all the way through and getting to the end. It's greatly appreciated. Right below me will be the entire PrintFixFriday series, and next to that will be our first look at the Prusa Mark IV's, a printer that I plan on heavily abusing in the coming months to test. Is it really that much of an upgrade, or is there potentially an easier way to get pretty darn close to the same performance out of a Mark IV? That's all we have for you all today. Stay safe out there, don't forget to call your loved ones, and as always, keep making awesome. Have a good one. Strings, shattering screens, feverish. Beetlejuice!